See, today we'll see sway analysis. When will happen? When will sway will happen? See, just observe it. If it is a loading is symmetrical, there is no sway. What is sway? Sway is the structure is moving right or left or up and down also. It's moving. It's moving. Okay. There is no elastic deformation. Elastic deformation is we can consider. Without elastic deformation, it's just a moving. So if in structure analysis, we just first class we called as whole the structure is moving from one place to another place without elastic deformation. We call it as unstable. So see one thing you can observe it. So these are the two rollers. If you apply a small load, it will move it. It will move it. Na? So we call it as unstable. But in these structures also, it is moving without elastic deformation. But it is not a whole, but some not a part, but it is considerable amount is moving. So how it is considerable amount is moving. So we'll see that is called sway. Okay. So if total of the structure is moving if you applied a very small load, that is called unstable. We already discussed in the first unit. But in these frames also, it will give considerable deformation, not an elastic deformation, considerable movement from left or right or down or bottom. Okay. So how it is happening? There is no sway. If you see, there is no sway at all. It is deformed like how can you can easily draw. Now onwards you can easily draw elastic curves. How can it deform? It is deformed. It's maintained 90. It's maintained 90. It will deform like this, na? Like this. So if you see, next I will ask. I will give this problem. If it is some applied load is applied like this, what will happen? It is moving, na? It is moving. It is a B is a beam. Beam is moving, but it's not a axial deformation. Just is beam is A beam is just moving. How it is move? How it is move? It will move. That means what? See how it is deformed? It is deformed. Maybe it will deform like this. It is deformed like this. So okay, so it is a displacement, not elastic deformation. So we call it axial deformations are negligible. Axial deformations are negligible. There is no axial deformations. Okay, but it is a total movement in horizontal direction because of horizontal load. So this is called sway. This is called delta. Some delta movement is so displacement is there. So if you consider the displacement, what will happen? What is the extra thing you can notice it? So okay, AB beam is just moving horizontally, but there is no problem. But if you see, if it is some D in AD column, you see it is D's support is displaced. So how it is look like? It's look like it is adjusting. It's look like sorry. It is look like this, na? You taken this. That is also giant, fixed giant, na? So if you see, what will happen? This is a delta. So what will happen? Considerable amount of movement is definite. What is that movement? 6A by delta L square. That's it, na? 6A by delta L square. Delta means that delta L square is generating, na? Support is sinking like. The support is displaced. It's not a support. A is a hinge joint. Joint is displaced. So through joint is displaced, extra moments will generate. How much? 6A by delta square, 6A by delta square. Whether if it is D is a hinge, if it is a D is a hinge, what will happen? How much amount is generated? How much amount is generated? The amount is generated 3A by delta by L square. This is 0. It is because hinge, na? It is 0. We already discussed previously. Okay, so that will happen. It is called sway. So we have to consider this delta also. Then we have to analyze the frame. So without sway also you can do it. So we didn't consider delta, we will do the problem, but those are the accurate. Those are not an accurate. We have to consider delta also. Are understood? So that's the called sway analysis. If you consider the delta, some maybe we don't know, but we can calculate what is the delta also. We can take into the consideration of the displacement of these joints. Considerable displacement. These are not deformation. It's a displacement. Understood? Displacement, deformation. Okay. So that's how will happen. We have to consider this way. Then we have to take this considerable amount of these moments also. So taken the support is like displacement, we can fixed end moments are generated. Okay. So when will sway happen? This is the one time horizontal load is acting. Horizontal load is acting. So second situation. If another situation, I will take it. Eccentric loading is happening. Are understood? Eccentric. It's not a symmetric. It's eccentric. If it is an eccentric loading is acting, what will happen? It will displace, na? Again, same. It will deform like this. So okay, it deform. It will give delta. Eccentric loading happening. Okay. Eccentric loading. Sir, which side is falling? Which side is tilting? No need to consider. We can take one thing is taken. We can do calculations. We can get positive. That direction negative is an opposite direction. No problem. Okay. But you can guess. You can guess it. Otherwise, just took with the very instruments near to you. Just took that frame and apply eccentric loading. Just observe it. Which side is tilting? Guess it, na? You can easily guess it. Okay. So this is eccentric loading. Which side is tilting? You can guess it. So next thing is if it is exactly symmetric loading, but if you consider this has a flexural rigidity I, this has 2I. 2I means this shape size is different. I means what? Shape na BED cube by 12. So that size is different. So flexural rigidity is different. Flexural rigidity is different between two columns. What will happen? What will happen? The same situation will arise. Same sway will happen. Which side it will sway? So again, you can guess it. Same will happen. Guess it now? Sway will happen. Eccentric cause. So flexural rigidity. Flexural rigidity is different. Are understood? So next, another phenomenon. So another phenomenon is sir understood? So this one length is L1, this is L2. Again, if you applied symmetric loading also, what will happen? What will happen? It experiences sway? So compulsory it experiences sway. Compulsory it experiences sway. Sway is experienced, na? Sway is experienced. Sway is experienced. Different length of column. Geometric property. Geometry. It's a geometry. Okay, it's a geometry. It's called dimensional property. Dimensional property. So, okay, it's a loading property. By loading, by dimensional disorder, or by geometry disorder, by loading disorder, you can call it as anything. Are understood? So that's it. So these are the different types. Maybe in some other cases also you can get it experience sway. But one thing you can observe it, if these are the shapes, if see, if the support is there like this, can experience sway? No chance. Are understood? Same thing, if you had experienced some support, no chance. If you experience some support, no chance. Chance is there? No. Not only this side, you can get it in this side also. If you have a support, not only fixed support, if you get as a hinge support also, it can't experience sway. Are understood? See, same thing. Yes, it experience sway. Anything, eccentric loading or something, anything, it can't move. It can't move, it can't displace, because it has a support is there. So it can control this way. Are understood? So how we can solve, sir? We will see. Directly do the problem, no problem. So very small problem, very extra. We require just one equation. So that one equation is just needed. You already, I said it's. So the extra thing you require just, if it is fixed and it is a fixed joint, so taken it will consider 6ei by delta by L square, 6ei delta by L square. You know it. And if the same thing, the support is hinged, this is a fixed joint, is the fixed support and a fixed joint. So that is a rigid joint. You can call it as rigid joint. Rigid joint behaves as a fixed joint. So it experience. So it gives slope. It gives slope, but there is no slope here. So it experiences moment is how much? 3a by delta square. We derived that proofs previous back, way back. Otherwise you can check it. Okay. Otherwise you can check this. These two is sufficient. These two will sufficient. Okay. How can you sufficient, sir? So see it. See it. So today we will take one problem. One or two problems we will do. Okay. First we will consider eccentric loading. Eccentric loading. See, one problem will take it. Both has a fixed supports. Both has fixed supports. E is a 2i. Columns has same flexure rigidity, so there is no chance to sway. But one thing, he gave the load of 100 kilonewtons. So that is the eccentric load. It's a 2 meters. It's a 4 meters. It's a 4 meters of height. That's the chart. That's the picture. Can I experience this way? Can I experience way? So which side it will go? It will go otherwise. It will go like this. So okay, we will draw. So elastic curve later. Okay, based on the deflection. Based on the deflection, it's a positive or negative. We will try. Okay, so you can experience. You can see it experience a delta. It's a delta. So the support, if we call it as A, B, C, D, BC beam is displaced by delta. Are understood? So displaced by delta. So I can clarity. It will maintain 90. This is 90. Okay. I can't show later, but I will show later. Okay. See how we can solve this picture, this problem. So see, it has a displaced delta. So okay, just place in mind. So no need, just write down the fixed end moments. Fixed end moments is MAB is 0, MBA also 0, 0. These are the 0. So there is no loading on AB, so we can get it directly 0. That's it. Fixed end moments are 0, no problem. So MCD, MDC, these are all 0. There is no loading on column. But MBC is what? 100 2 4 square by 6 square. What is that value? 100 4 6 square. What is that value? 88.89. It's a negative. Negative, na? So just take it. Fixed end moments. It will come like this. It will come like this. Okay. So CB is same, 100 2 square 4 by 6 square. What is that value? 44.44. This is a positive. That's it. Fixed end moments. Now we can write down the slope deflection equations directly. MAB is what? MAB plus 2EA by L. So 2 theta A plus theta B minus 3 delta by L. So now if you see that one, MBA is what? MBA 2EA by L, 2 theta B, theta A, 3 delta by L. Now you can observe it. MAB 0, MBA 0. Theta A is 0 because it's a fixed support. Theta A is support. Theta B has rotation. I already said it's a fixed joint. Fixed joint is behaving. If it is like this, it may be experience. It maintain 90. Otherwise, it is like this. Otherwise, it maintain 90. It may be anti-clockwise rotation or clockwise rotation. So everything I like this. It's a clockwise. I assume it's clockwise rotation. So exactly we have to draw like this. So I will draw diagram neatly later. Okay. So it's maintain 90, but it's a joint, na? So it can rotate it. We already discussed. So theta B is there, and now delta. So delta is there. Today B joint is what? B joint is moving. So for that, see, AB is there. It's moving. How much it is? Delta. It's moving now. Moving. We can take it as a 6CA by delta square. It is a 6CA by delta square. That's it. Huh? It's develop. So negative, anti-clockwise, develop. So we included 6 2EA by L, 3 delta by L square. That means what? 6EA delta by L square. We included in the slope deflection equations also. But previous problems we solved it. There is no delta. There is no support settlements. We just avoid. But now you see, observe it. Delta is there. So what is delta? We don't know. But you have to take delta is there. So observe it. Same 6A by delta we included. How we write the slope deflection equations? Just go through previous. Okay. So that's it. That's the only difference. Okay. That's the only difference. So now you will come to BC. MBC 2EA by L, 2 theta B, C delta by L, MBC, CB, 2EA by L, 2 theta C, theta B, 3 delta by L. So now we observe it. Once again observe it. It has a 2I, not I. So we include extra 2. One thing. And also theta B is there, theta C is also there, because those are all joints, not a supports. Support has a hinge support is 0. Hinge support has a deflection, but fixed support has there is no rotation. But theta B and theta C are joints. Joint has a rotation. So we have to calculate it. But delta is there. Just BC is there previous. Now the BC is moving, the just it's moving from this axial direction displacement, but there is no support settlements. Transverse displacement is not there. There is no extra moments will generate. If it is like this previously, it will now it will move it. There is no extra moments generated. Are understood? Just it's moving. There is no extra moments generated in the BC. There is no delta. Are understood? So that's it. I want to understand. You want to understand. There is no delta. Okay. That's it. Next, MCD. MCD. You have to take it same. CD 2EA by L CD minus 3 delta by L. Okay. MDC 2EA by L 2D DC 3 delta by L. It's now exactly that's it. So if you see theta D is 0, so you can take it D 0, and MDC also 0, and also delta is there na? Delta is there. Delta is there once again. If you see, it is the previous. So now it is there na? It's a C, it's a D. Now it is anti-clockwise movements are there, exactly there. So you have to take in its delta. But if you see, these both deltas are equal. Are understood? So BC is there, and now it's experienced this moving. There is no axial deformation in BC. So compulsory this value should is equal to this, should this equal. Both are equal, na? Both are equal. There is no chance to differ those two values. If you see, there is a chance when the AC has when the BC has an axial deformation, we consider axial deformations are negligible. No chance at all. We didn't consider anything. There is a chance when these two deltas are doesn't equal. When that chance BC experiences axial deformation, we consider there is no axial deformation. Are understood? So these two deltas are equal. Okay, that's it. That's it. And take in consider what is that? This length is 4, this length is 6. Okay, 4, this length is 6, 4. So how many unknowns are there? This value is minus 88.84. This value is plus 44.44. How many unknowns are there? We have unknowns of theta B, theta C and delta. 3 unknowns are there. We required 3 equations. We already know 2 equations, sir. What is that equations? Giant equilibrium equations. Giant equilibrium equations. What are those giant equilibrium equations? The moment at B giant is 0. Moment at giant C is also 0. We know it. So what is that know it? MBA plus MBC is 0. We already know it. If any other concentrated moment is there, we have to take in that is equal to the text concentrated moment. Yesterday we solved it proper. So MCB, CCB, MCD is equal to 0. We get 2 equations. Giant equilibrium equations. But third is unknown is there. So you don't get answers. By 2 equations. We have 3 unknowns. 3 unknowns are there, but we have only 2 equations. Sir, how can you get extra third equation? That's it. That is the whole problem. How can you get? See. Get it? How can you get it? See the free body diagram now. So free body diagram of that A, B. Free body diagram. You will observe it. So observe it. It has a moment of, so final free body diagram, we have to take it as a clockwise directions because we write in everything is in a clockwise direction. MAB, MBC, everything we write in a clockwise directions. So finally it gets some value, moment. We don't know that moment which direction, but everything we write in these are all in clockwise directions are taken as a positive. Later we will get negative or positive, we don't know. So I write in the free body diagram. Okay, so it has a moment of MAB. It has a moment of MBA. Final moment. Maybe it is positive or negative. We don't know. Final moment. We know it. It's a free body diagram. No? Yesterday we wrote free body diagrams. Otherwise, just see it. Yesterday where it is. Yesterday we clearly draw. How can we draw free body diagrams? So everything we show it. Once you get the moment. So now we didn't get any movement. We don't know the direction. So we just write it. It's taken as MBA as clockwise. Okay. So okay. So MBA. These are all. MBA is positive, negative. We don't know. The final moment. MBA is small level. So this is a free body diagram. So just see it is. Just see it is. It experience. See. It has a delta. We don't require. Okay. So if you just see it is, observe it. It is experiences sway. It experiences sway. It is tilting towards right or wrong, right or left. We don't know. But compulsory it experiences a horizontal force. Na? Horizontal force at support here. It's getting horizontal support. Na? Compulsory it will getting air. So it get exactly if it see. So otherwise I will write. It is like this. If it is tilting, otherwise so if no need to consider. So it is tilting one side. Is tilting or one side. Compulsory it experience a horizontal force. Na? It experience a horizontal force. Compulsory if it is exactly symmetric, there is no chance of horizontal force. There is no chance of horizontal force. But if it is tilting, it will experience a sway. Compulsory it will experience a horizontal force. Horizontal force, na? Horizontal force. And also you will see exactly it has a symmetric load also, it will experience a horizontal force also. If you see, we already see in arches, exactly loading is there. We experienced a thrust, na? We experience the horizontal force. Compulsory it experience. In frames also, in first unit, energy principles, we calculated that H also. Or observe it or not. So we will get a H. See, one thing is just observe it. If it is there, if it is a rollers, if you put a rollers, just applied any load. If it is moving, that means what? It is moving means one direction it has a force. It is tilting means what? It has one direction, it has one force. If it is not restricted that force, it is moving. So compulsory it experiences one horizontal forces are there. So to curtail that movement, see just apply rollers, it is moving. Both sides roller, it's moving. So compulsory you have to provide a fix. If you provide a fixity that curtails the horizontal movement, that means that experience the horizontal force. Are understood? So it has a horizontal force. It has a horizontal force. Or which direction? We don't know. Okay, you can take it anything. No problem at all. You can take anything. So now I will take this direction. So later it will get positive. Our direction is okay. Later will get negative. That means what? It is experience opposite direction. Generally, if you think it is moving like this. You have to get a horizontal thrust is in this direction. That's it, no? That's it. A general feeling. I think I will get a horizontal thrust is negative direction. So negative value. Maybe I have an imagination. That's it, no? It is moving like this. You get horizontal thrust in this direction. Then only if you see it is moving like this, that means it has the inertial force. You have to compulsory maintain equilibrium. So understood? So I will get negative H, I think. But okay, no problem. So that's why. So took HA. Or took. So that's it. So these are the free bodies. So it is a HA. So automatically it can HB. Both are equal. Both are are understood? So now you observe it. So this is a free body diagram. Vertical forces, no. Moments MAB and MBA. Horizontal forces, we write it. We wrote it, na? We wrote it. So now we take it. Now we take it any equilibrium equation. Any equilibrium equations. Take it any equilibrium equations. Now I will take equilibrium equation with respect to B. Moment at B is 0. Moment, not a bending moment. So at one end, moment at 0 equals 0. Moment is 0 everywhere. So take it. So what will happen? So what will happen? See. So HA into this height. This height is what? I write is L. HA into L. HA into L. So this is opposite MAB plus MBA is equal to 0. Because we write it with respect to B. So the horizontal force is in the direction of the B. There is no perpendicular distance. There is no moment experienced through HB. That's it, na? That's it. Is equal to G. Is equal to 0. That is the equilibrium equation of that free body diagram. Are understood? That's the equilibrium equation of free body diagram. Otherwise, you will take it with respect to A also. You will take with respect to A moment, not a bending moment, and moment also 0, because we write it. Bending moment is there. BMAB is already write it. So moment is 0 everywhere. So we already experienced now. It is a fixed B. It is a loading some P. So what is that? It's P into L. So it will experience PL. So moment at everywhere is 0. It is AB. So we will take moment at 0 B. So P into L, that moment is, this is a moment. M is 0. What is M? M is also PL. Write it now. So that is a free body diagram. So you can took moment at every place is 0. So otherwise, if you take an MA equal to 0, moment at A is 0. So same thing will experience HB into L, MAB plus MBA is 0. HA, HB are both are equal. Both are equal. Na? So no need at all. So that's it. That's the one equation. Based on that, you can write it MAB plus MBA. MBA divided by L is equal to HA. That's one equation. Got it? Got it. So based on that same thing, I will write the equation for CD. CD. There it is. CD. It's a CD. It's a C. It's a D. Understood? Same. I will took the direction is HD like this. Like this. Okay. So same it experience clockwise. MCB CD MDC. It has length. It has a length. It's called L1. It has L2. Both are equal. Present problem. If a different is there. So same. You write and say HD. It's also come HD. That's it. Na? If you write moment at with respect to D or with respect to C, you can take it as anything. What you will get? MDC plus MCD divided by L2 is equal to HD. That's it. Na? That's it. These are the two equations we get it. If you observe it, so HA, HD, you got two horizontal forces. But if you see this picture, if you see other picture, there is no horizontal force is there. There is no horizontal force in the structure. So what is HA, HB? So this has HA, this has HD. So if you want to equilibrium, if you get to the equilibrium situation in this situation, total horizontal force also should be equal. Na? Should be equal. If you see HA plus HD compulsory equal to 0. Because there is no another horizontal force in the system. HA plus HD should be 0. Otherwise, are understood? So that's it. There is no another force in the system. There is no another horizontal force in the system. So HA and HD should be 0. If you observe it, so already I see it. One thing it will go, one thing it will go. Are understood? One thing it will go, one thing it will go. So we already see it. One thing it will come, one thing it will come. Understood? So we already know it. So that's it. That's it. Based on that, we can get a one HA plus HD compulsory 0 because there is no another horizontal force in the system. So this is one another equation, third equation. So equation third is what? MAB plus MBA by L1. So MCD plus MDC divided by L2 should be 0. So now L1 L2 are equal. So write down. We already write down MAB, MBA, MCD, MDC. We write down, we already there, and two equations also there. These 2 and 3. 3 equations. 3 equations, 3 unknowns. Can you solve it? Can you solve it? Can you solve it? Can you solve it? I will write the equations. I will write the first 2 equations, later equation, this equation. Both 2 equations now. So both 2 equations, and this is the third equation. Both 3 I will write it like this. I will write like this. How can I write it? Simplified. These 3 equations you will get like this. Just solve it. If you have, I will give one suggestion. Every time you have to write, I didn't give any EI value na. EI theta B, EI theta C, and both 2 are there, and delta is there. So delta also associated with EI. So EI delta are there. It will come so many times you have to write down. So I will give a suggestion. Just take this value X, this value is Y, this value is Z. So for the solving the problem, you can feel better. You can beat better now. So that's why you can just take it as a simple arithmetic problem. You can just feel it and you can easily solve it. Because 3 unknowns are there, every time you have to write an equation, you will every time experience X, Y, Z. So that will easily. Okay. So now I will give these 3 equations. 3 equations, how they will end is like, so 2.333, 0.676 minus 0.375, 0.6667, 2.333. How these 3 equations will end like this: 0.37, EI theta B, EI theta C, EI delta. Those are the 3 equations. You will write it, you will get like this, is equal to the 88.49 minus 44.49 is 0. Okay, minus. Sir, this is negative, this is positive, sir. No. If you just solve it, you will get it. First equation you will get like this. Okay, first equation is will get like this, is equal to this. Second equation you will get like this. Third equation, M is equal to 0 na, is equal to 0. You will get like this. You will write in matrix form, but you can't. Don't need. You will just write down 3 equations. It will end like this. Later you can 3 equations, 3 unknowns. One in terms of others. Otherwise you can use matrix in your calci. You will solve it and you will get, what is that? EI theta B is 49.87. EI theta C is minus 30.12. EI delta will come 19.753. Okay, these 3 values will come. So just place these 3 values. Just place these 3 values into these equations. You will get MAB, MBC, MBC. So I will write what is that values. MAB, MBA, MBC, MCB, MCD, MDC. What is that values is 17.53 positive, 42.47 minus 42.47, 37.53 minus 37.53 minus 22.47. These are the values. Okay. Extra one thing is, we consider delta. To solve the delta, we need extra equation. What is that extra equation? This is the extra equation. That's the only thing in sphere analysis. Okay. That's it. That's enough. And you can find out the h also. You can find out the h. So how can you find out h? HA is this na. HA is this. You can MAB plus MBA by L1. So MEBA H is what? MBAB MBA by L. What is that value? 1746 50 59. 59 divided by L is what? 59 60. L is what? 60 divided by 4. It's a 15. It's a 15. Are understood? And also it will have positive value. This HA, HD also will get same 15 value. HA plus HD is, but negative sign will come. But if you see it's a 15 is positive sign will get, what is that mean? That mean is what we assume direction is right. Assumed direction is right. So our assumption is wrong. So 15 is right. We taken this 10, it is 15. It is opposite to 15. Opposite to 15. And also delta also you can find out. See delta also what you see, what you find? EA delta, it's also getting negative positive value. That means what? Our assumption delta, our assumption so movement of left or right is positive. So that means what? Our assumption direction is right. If you get negative, it's the opposite direction. So no need to fear to take right side or left side. You can take in any side. Are understood? That's it. That's a 15 and 15. So now you can draw Benjamin diagram. Now you can draw Benjamin diagram. Benjamin diagram. See, first I will draw Benjamin diagram for BC. BC. See, BC is negative. So you will see, observe it. BC. BC is negative anti-clockwise. CB is positive. So that means both are hogging. So both are hogging. One is 37. Another one is also 37. You can write is 37. But it's supported by 100. So you can take it as a PL by PAB by L. PAB by L. Na? So PAB by L. What is that right? You can write is that is a. That's it. These are all cancelled. So this is negative, positive, positive. This value is just find out with. This value is generally PAB by L minus of 37.53. This is a 37.53. Na? This is 37.53. You can find out PAB by L and y. So that's it. That's the thing. So for this beam, for this column C it is. MAB is 17.53. Positive. Positive means, so you can just observe it. Positive means clockwise. Clockwise means in this direction. MBA is again positive 42. It's this direction. See it is. This is a hogging. This is sagging. So now we have to write down. This is a hogging. This is sagging. So which number? It's a 42 and 17. This is 17. This is 42.53. So here take it. There is no another loading is there. Otherwise, just we observe like this. So now you can write down the plane for this CD like this direction. You can rotate it. See, same thing you observe it. MCD is negative. MCD is negative. Negative means anti-clockwise. MDC is also negative. MDC is also negative. Negative means this side. That side, na? So that side. So this is at sagging. This is all sagging. This is hogging. So what is that value? This is 22. This is 37. So you can write koncham height. So you can add it. So that's it, na? So you can observe it. This is sagging. This is hogging. Negative, negative. This is positive. Are understood? That's it. That's it. Otherwise, you can write down the same diagram like this. like this, because see this value, what is that value, you can find out value. And also you can find out, you can write down the shear force diagram also. Shear force, see the AB column is, so column you can take it as a column, is a column. Shear force na? Just shear force, it has a 15, it has a 15. So what is shear force diagram? Shear force is just a 15 for that AB, for that AB. Understood? For that CB also, you see CD also, you will get the same. For BC, there is no shear force, but you can observe it. It has a 15. It has a 15. That means what? BC has an axial force of 15, not a shear force. It's not a shearing. It's a 15 axial force. Are understood? So you can write it's 15 axial force. It has 15 shear force. Are understood? It will come. So for BC, it will see. It's a BC is a beam is there. It's a 15 is there, and it's a 15 is there. So you can draw in free body. It has B. It's a 15. So it will extend here. Every joint has also equilibrium, na? So that's why it is a 15. 15 of this beam. This is a 15. This is a 15. So it joint, the joint of this B. So you can write 15. It's a 15. So that means it has an axial force. Axial force. So you can write shear force and axial diagram, axial force also. In sway, it experienced axial forces one beams and columns experience shear. That's it, na? That's it. It has completed of 1 hour. But I want to explain another problem also. But okay. That's it. That's the enough of the story of this sway analysis. But tomorrow also we will solve another two problems. So that's the end of the story of the slope deflection equations. But I have an interest to tell some small problems, gate oriented problems. So I will explain some small problem, not a small problem. If you see, if it is a small fixed end beam, it is A, it is B, A and B. Okay, A and B, it has a P. So what is the slope at B? Sir, it's a proper cantilever. We have to find out the slope through proper cantilever. So strain energy method or something, any method. Different methods are there na, to find out the slopes. First you have to find out the bending moment diagram. Later you can find out so much different diagrams are there. Later area moment method, conjugate beam method. But in slope deflection method is very easy. How can you easy, sir? Write down the equation. MAB is what? Fixed end moment is what? PL by 8 na fixed end moment. It's negative 2EI by L 2 theta A plus theta B. MBA is what? PL by 8 2EIL into 2 theta B plus theta A. That's it. Na? That's it. You already know theta A is 0. Cancel. Only theta B is there. Theta B is there, na? So this is only one unknown. We get one equation. What is that equation, sir? Equilibrium equation. The MBA is 0 because it has a hinge joint. It is 0 means what? PL by E 4 theta E B by L is 0. So what is the theta B? Theta B is what? Minus PL by 8. Theta B is minus PL square by 16 EI. That's it, na? That's it. This is the theta, na? This is the theta. That is theta. You've already experienced. I think you know it. PL square by 16 EI is the theta. Otherwise, if you see it is, if it is uniformly distributed load, it is also easy. What is the just changes? This is WL square by 12. WL square by 12, na? Just see it. It's WL square by 12. Take it as 4 EI theta B by L is equal to minus WL square by 12. So what is theta? B minus WL cube by 48 EI. How simple it is? So you can solve simple problems also using slope deflection method, but I don't want to say these are the very very simple problems. These are the objective questions, that's why I skip it. You can find out the slopes very easily, very very easily through slope deflection equations. Are you getting? Slope deflection equations very very easily you can get it. You can get it, and also MAB also you can get it. MAB is also you can get it, because once you got theta b, you can just place in theta b, you will get this fixed end moment, this fixed end moment, this fixed end moment. So these are proper cantilevers. These are the proper cantilevers. Why it is easy, sir? It has only 1 degree of freedom. 1 degree of freedom. This is theta b. 1 degree of kinematic intimacy, and also static intimacy also is 1. But the static intimacy procedure is somewhat hectic procedure. But in a slope deflection method, it is a simple process. To get the 1 degree of indeterminacy is only one equation. That one equation is MBA is 0. So very simple. It has also 1 degree of indeterminacy. So you can, these are the 1 degree indeterminacy. So we skip those problems. We already solved the problems of at least 2 indeterminacy. At least 2 indeterminacy we solve it. But you can use this. You can use this and you can get any slopes. Any slopes. Okay. Any slopes. Easy. Very very easy way. You can't you don't want to remember those moments, everything, proper cantilever moments. You can just solve it in within 1 minute. You will get the answers. Okay, these are all used in, you can use it in gate problems or very objective problems. Okay, that's it. That's what I want to say it. Tomorrow also I will say at least 2 problems, another 2 problems. Then we can stop the slope deflection method. We can go to the moment distribution method. Okay, that's the thing. 13th and 14th surveying, see structural analysis, surveying and exams. Okay, remembered it. First 3 units, just prepared it. It has a lengthy paper. You can take at least 2.5 hours. Okay, solve those problems. You can just practice those problems. You can put your textbooks in front of you and you can write it, no problem at all. Just do the problem, that's it. That's I want it. Okay, if you have any